Today's notes are on the subject of energy. You will take notes in your notebook. Please use your agenda for the correct pages. Make sure that you include all information. Remember, you can always pause and rewind the video as much as you need to make sure that you have all your notes taken. By the end of this video, you will know the different types of energy and how energy can be transformed from one type to another. Let's begin. Let's start by simply defining energy. Energy is the ability to do work and cause change. However, to understand what this definition means, we really need to make sure that we understand all parts of the definition. Of course, the first thing that comes to mind when we think work, we think of a job. In science, this is not the definition of work. Scientifically speaking, work occurs when a force is applied over some distance. To understand that meaning, we need to analyze the definition a little deeper. When you apply a force to anything, it will either be that of a push or a pull. So if I wanted to come up with a really thorough definition of the term energy, I would say that energy is the ability to apply a push or pull over a distance and cause change. Now, just like all matter fell into two main categories of pure substances and mixtures, we can also fit all types of energy under two main categories: kinetic or potential. Kinetic energy is energy that is in motion. So the writing that you're doing right now is an example of kinetic energy. However, the supply caddy at your table is an example of potential energy. Potential energy is the opposite of kinetic energy. With potential energy, it means that the object has stored up energy waiting to be used. Energy transformation is when energy changes from one type to the next. The fact that no matter was created or destroyed in the process is the law of conservation of energy. There are both single and multiple transformations of energy. Before we get into that, we need to look at the different types first. But even before that, let's focus on the transformation between potential and kinetic. Let's consider the following example. When I'm driving, my car is moving and therefore that is kinetic energy. However, once I get home after a long day's work and park my car, the energy that once was moving energy now turns into stored energy. That energy will remain stored until I turn the ignition on and start driving again the next day. There are many different types of energy. There's mechanical energy, which is due to an object's motion or position. Then we have electrical energy, which is the energy flowing from electrical charges. Light energy, also known as radiant or electromagnetic energy. It can be man-made or natural, and it's the only energy that we can actually see. Then there's thermal energy. This energy is related to the motion of particles. When an object is hot, it has a lot of thermal energy because the particles are moving quickly. Thermal energy is also known as heat energy. Next is sound energy, and this is just the vibration of particles that help produce the sounds that we hear. Next, we have chemical energy. Chemical energy is energy stored in atoms and molecules and released during chemical reactions. Finally, there's nuclear energy, which is the energy that is inside the nucleus of an atom. The remainder of the school year, we will focus on the main types that are highlighted. To help you remember them, we use the acronym MELTS, M-E-L-T-S. Now pause the video here and go back to page 77 in your notebook. See if you can write the type of energy necessary for the examples you listed as requiring some type of energy. When you're done, start the video again. So which types of energy are kinetic and potential? Remember, kinetic energy is moving and potential is stored. In your notes, write a K or a P beside each type as we review them now. Because mechanical energy is based on the object's motion or position, it can be either kinetic or potential. Electrical energy flows, which means motion is involved, making this energy a type of kinetic energy. Light energy is in constant motion through waves, making it kinetic also. Remember that I said thermal energy focuses on the motion of particles in a substance? Well, that makes it kinetic also. Moving particles make sound energy a type of kinetic energy. Now, for examples of potential, we have chemical and nuclear from our definitions from before, which place them into the potential category. However, two other types of energy not already discussed are gravitational and elastic potential energy. Why don't we go ahead and click the Hoodwink link so that we can see how these types of energy are applied. Now that we have the types down, let's look at how they transform. Remember, the law says that energy can only change, but is never created or destroyed. We can have single transformations and multiple transformations. A single transformation is when we start off with one type of energy and it changes into another type. Look at the example of toasting bread above. To toast the bread, we first must plug in the toaster, then the electrical charge is changed to heat energy that helps to brown the bread. Then we have multiple transformations. These occur when we start off with one type of energy, but it changes into more than one type. So when you turn on a lamp, those electrical charges flowing from the outlet to the light bulb help to produce the light that we see, and it also produces heat. So if you were to put your hand close enough to the light bulb, you can feel the heat, but please don't touch. Now I want you to come up with one single transformation and one multiple transformation and write them in your notebook. This will conclude your notes for this topic. Make sure to go over your notes and then bring questions in class for more assistance on the subject.